All right. Hello, everyone. I think we are ready to begin. Yeah. So, okay. Let's take care of any announcements we have. So let me just drag down a live board. Let's see what kind of announcements we have. So I guess just remember that homework 0 and lab 0 are due today, right? And yeah, hey, look at who it is. It is you. You are now a moderator. So, okay. Yeah, so remember that these are due today. Is my microphone really low? Let me check. Is my microphone really low? Let me check. That sounds okay to me. I can turn it up a little bit. Nope. It's due. These are due on the 9th, which is today. Homework 1 and lab 1. Those are due Friday. And just so you kind of get into the rhythm of it, homeworks and labs after homework 0, which again is not really a homework, are going to be due on Fridays. So we will assign homework 2 on Friday, and usually I'm going to do it probably midday sometime. And that means anywhere between like 10 a.m. and say 3 p.m. It just depends on when I finish and proofread. And then I'll dump it out at about that time, and then we'll go to the next Friday. And so lab 2 will be assigned in lab, so you'll get it then, and then it'll be due the next Friday. And so that's how this generally works. Okay, so I think, is that it for announcements? I guess the last announcements are, if you cannot submit right now, apparently we are not supposed to do, so you have a week to do homework. That is correct. You have from a Friday to the next Friday, right, to do homeworks. And so, what else should I say about this stuff? I think that's basically it. The only last thing to say is that if you still can't submit homework 0 today, then you should still send me an email, and I will have to give you an extension on it. The extension is because we are not supposed to mess with the submit system on the day assignments are due, so I can add people tomorrow, but I can't add people today. Otherwise, it might actually close the homework 0 assignment for everybody. Yeah, so I sent out a homework 1 announcements. Yeah, so if you ever want to know where to find this stuff, basically all assignments are going to be, except for labs, are going to be sent out via an email announcement on Blackboard. They're going to be posted in Discord announcements. Well, so if you didn't have Lab 1 on Labor Day, then your TA should have just sent you out the Lab 1. Lab 1 is kind of like an easier version of Homework 1. You should be able to do it really quickly. This is just right. Yes, I understand. So, yeah. So lab 1 should have been sent to you by now. It should be in your lab section. Right? You should be able to find it at this point. If you can't find it at this point, contact your TA and have them send it to you. Or have them send it out to their entire lab section. Oh, yes, that's the next thing to talk about. So this week, discussions did not take attendance. But next week, we might start. So there may be a check-in command that you can post in your Discord. And if you post this check-in command, it will give you the points for it. And so then you'll have to, so you're going to have to do this twice. You're going to have to do this one at the beginning of your lab, and you'll have to do this once when your TA tells you that the second check-in can be done. So you'll have to do this twice, and that'll count as attendance. And of course, the reason for all of this is to ensure check space in that you at least go to discussion for about 15 minutes. So if we didn't have discussion yet, we haven't been sent lab 1, that would be correct. So, I can't, so it's hard to make a universal statement because I have discussions that go from Monday all the way to Thursday. So if you haven't had discussion yet, then you will have it tomorrow, or you might have it today. So, academic integrity quiz. I don't know why everybody's asking about this. Does everyone want exam 1 right now? The academic integrity quiz is given before project 1. So it's not something that is even, it doesn't even exist yet. It's due on Friday for everybody. The labs are all due on Friday. Labs all due Friday. Okay. All right. So I think I've spent way more time than I should have on announcements, but that's good. So, all right. I think that's it for announcements. And I might make a little video, a little tutorial about this check-in feature. Currently, it's about I don't know, maybe 1/3 to 1/2 done. And so I need to make it 100% done for next week, which I think I can do. The only problem with that is that I just need to have like a few hours, or maybe an hour or two, just to sit there and this means I need to code it. So let me see what happens if I check into a lab right now. Let me just see. I'm not sure. It might, I don't know, it might break. Let's see. Let's go check it. And the 201, what does the 201 bot tell me? It tells me, we're unable to find you. Talk to your TA. Because I'm not a student. Okay, cool. So what if I do it on my fake student account? Here we go. All right. This is not the correct date for discussion. So it's kind of working, right? I mean, it's yelling at me in the correct ways. and it's not letting me do what I want to do. So I might have to yeah, that's my yo, Ben, you want to join in? I'm about to actually start the class now. All right, hang on. You want to call me up? If you get annoying, I'm gonna boot you though. Just saying. Okay, where are you? You should call me on Discord. All right, there you are. Hello? Huh. I cannot hear. Let me turn on desktop audio. Let me try again. Huh. I don't know. I can't hear you. Not sure why. Have you done something with your Discord settings? Have I done something with my Discord settings? I have. Look at me. Hang on. Hang on. Try again now.
Hello.
All right. That's no good. Let's try one more. And then we're seriously gonna do this class. Okay. Here we go. I hear you
Hello?
typing now. Yeah, you're here.
Oh, yeah. Okay. Excellent.
I have way too many freaking audio devices, and so every time something gets jostled on my computer, they're all like, I want priority, and then Discord's like, hey, who gets priority? And then it literally just craps itself. So, all right.
Okay, so I have just one question before we get started.
No.
On the abstract scale, 0 to 1 inclusive.
Definitely 1. Go ahead.
Oh, I was about to say, how disruptive should I be today?
Oh, okay. Let's limit it at like a 0.2.
0.2. All right. Okay. I'll crank the dial down to 0.2. You let me know if it needs further adjustment. But what are we talking about today?
If statements.
Oh wow, this is incredible power that they're gonna know how to decide things with the codes.
Right.
Wow.
So basically, up until this point, all we've really taught them is how to do printing things like print hello. They can print the number 3. They can print a floating point like 1.2. They can even print the Boolean true and false, and they can even print this random thing called none. So that's all the stuff they can do. And then they can input, right? So you can print, you can input. And so let's input some stuff, like input, tell me a thing, right? And so we can always just say s is equal to some kind of input, and then we can print that s out. So tell me a thing. The thing is that Dr. J is here, and then it prints that out. And so that's really all we can do. We can do essentially one more thing. We can cast, right? Remember, we can cast into int, float, technically bool, but don't do that for some reasons that are kind of annoying. So, yeah, so let's say the integer, right, equals int input. Tell me an integer. And float can, the float maybe, equals float input, tell me a float. So this is all basically review from last time. And
is there any more to programming? This is it, right?
Well, you know, the problem is that you notice that the code that we can do so far really doesn't do a whole heck of a lot, right? You can do calculations, basically you can do algebra, which no one really wants to do. You can do inputs and you can do prints, but the problem is that there's no, I guess there's no logic, right? There's nothing there's no decisions being made in this. It's just everything just happens, and there's no what would you say? There's no ability to change the direction of the program, so you can't make a decision based on what happens, in the inputs, for instance. Tell me a thing. What's the thing? No decisions. Tell me an integer, 5. Tell me a float, 6.5. And there we go. So this is what we can do so far. This is what we can do so far. Yes. So, basically what we're going to introduce now are conditions, or if statements, basically. So some languages have more conditions than just if statements, but I think Python really just has if statements, right? Wouldn't you say that, Ben? Oh, you muted yourself.
I did. Python has if statements?
Well, not just it. Does it have if statements? The answer is yes, because if turns orange. The question is, would you think that's the only logical control structure in Python, really? Like if, elif, else. We don't have.
It's the only one this is the only one you use if you're not being weird. So okay. Yeah.
Sure.
Yeah.
I think it's basically the only one. You could say that try except is one, but basically the only logical control in Python. Anyway, okay, so let's discuss. So now we have this little error after if. So what do we get to do with an if statement? So the idea of an if statement is that if the condition is true, so if condition, then it will execute the condition is true. So if I define condition here to be a true thing, now normally you're not going to make it called condition. You're actually going to have it be something related to your program. But if the condition is true, you'll just print out the condition is true. And so let me just comment out the rest of this code or do something, There we go. Now it's gone. So it prints out the condition is true. And if I set the condition to be false, then it will not print, right? So if the condition is true, then it will execute, right? So if condition is true, it will execute. If false, it will not execute. And I guess I'll capitalize true and false. Okay. So what are some examples of conditions that we can use here? So for instance, say we input an integer, so we say int input enter int. And we want to test to see if this integer is bigger than 0. We can have an if statement that says if x is bigger than 0, then print x is positive, right? So let's see what happens here. Oh, in PyCharm you can drag select some code and then just tab. So you can enter an integer that's 5. And it tells me x is positive. But what if we enter -2? And then it doesn't print anything because it's not positive. Okay, so what are some other kinds of things you can do? Well, let's just say you enter, you have someone tell you a string, and let's say if the string is equal to hello there, then you print out General Kenobi. I guess I have to escape that now because I always use expected, right?
Just nix the contraction.
Well, unfortunately, he is a cyborg and not an android, so he does use contractions. It's terrible. So So, okay, let's enter an integer. So is 0 positive? Is it? What's that backslash? That backslash is an escape sequence. We talked about it in the previous lecture. So as it turns out, 0 is not positive, and so it doesn't print anything. And now let's get our little print statement out. Hello there. Okay, cool. And then let's do something that is positive, 17,000. That's pretty positive. And then let's type in hello there, like this. Now, yes. So the double equals is a comparison equals, not assignment. So in Python, if you want to assign things, then you use this variable is equal to 2, and that's a single equal sign. But inside of if statements, you have to use a double equal sign. Don't use triple equals. That's like JavaScript. So, okay. All right, so tell me a string, and I'm going to type in hello there. So here's the question. Does this work? Right? Is it going to print out the General Kenobi string, or is it not?
It's definitely going to work. You have hello there in both places.
I know, right? It's 100% going to work. It's never failed for me before. It didn't work. Right?
But we've been expecting General Kenobi.
Yeah, well, I think it was just a little too emphatic. Let's try if 5 and then let's say hello there, right? Is this gonna work, right? That didn't work. All right, so let's just test and see if our code works. 3 and okay, so that worked. Interesting. So basically the moral of this story is that when you test for string equals, the case matters. All right, so that's kind of the point of all of this. And so, yeah, all right. Is there a to lowercase function? Yes, I'll talk about that probably, maybe later today, I don't know, we'll see. And in a lot of your programs, what you're going to end up having is basically a statement like, if user input is equal to quit, then you will print out, well, of course, maybe I have to define user input. It always sucks when you're trying to type an example and it yells at you for actually having to make your code work. So, what do you want to do? So quit, and then it says, okay, we are done now. Of course, it's going to quit regardless, because,
Hey, I have a thing I want to do.
What do you want to do?
I want the user to give me a number, and then I want to tell them if it's odd or even. Is that something we know how to do?
Sure.
I mean, I of course know you know how to do it.
Well, yeah. I mean, okay, we can do that now. Okay, so let's test. Let's test if and well, actually, I haven't. Is even or odd? Well, you know what I haven't taught them yet, because this is lecture 3. Is modulus.
Oh.
So
they're already clamoring for modulo.
Well,
chat.
Unfortunately, this is jumping ahead by like 2 or 3 lectures, but whatever.
Oh, is it? Oh,
well,
my
I
bad.
mean, it is, right? Because we don't teach mod for another few lectures, but that's okay.
Oh, I'm sorry. I'm deep in 341 country. I don't. Time is meaningless now.
Yeah, so well, yeah. Remember Labor Day, right? So I've only this is only like their second coding lecture.
Oh my.
Yeah, exactly. So anyway, okay. So we have some extra operation to do this kind of thing, and let's talk about it. This operation is called it's called mod, and in most programming languages, it's denoted by a percent sign. So the idea here is that what you can do is if you take a number. So let me actually just do a few examples. Um, yeah. D0. X equals m. Okay, so don't pay attention to the code so much, just follow along with what I'm doing. Okay, ASDF, oh crap. Of course, the code has to work. All right. Oh, maybe I should do it this way. Okay. So, 1, ASDF. Okay, so now we want to enter two integers, and I want to show you that modulus is going to give us essentially the remainder of the division of x divided by d. So whenever x divided by d, you're going to get a remainder, right? So at least whenever you, I should say integer divide. So the point is that let's enter 5 and then let's enter 2. And then let's think about what happens when we divide 5 divided by 2, at least back in elementary school, is really 2 remainder 1, if you remember this weird notation, right? So what it really is saying is that 5 is equal to 2 times 2 plus 1, so the remainder is 1. Now mod doesn't care about the quotient, I should say. It doesn't care about how many times the thing went in. It only cares about the remainder. So basically, when I write out this extra thing where 5 is equal to 2 times 2, modulus just ignores this part and just gives you back this 1. So let's hit enter. Okay, cool. So it gave us 1. What is 17 modulo 5? So when you divide 17 divided by 5, what is this, right? Well, it's probably 3 times 5, but then the remainder is 2. So this is, what mod gives us. Whoops, what have I done? Actually, what have I done? Okay. Okay, there we go. Okay, so what other kinds of things can we divide? What other kinds of things can we do? So here's a weird one. Minus 2 modulo 3. So this is asking us, okay, so that, yeah, so what happens when we do minus 2 mod 3? And so this is something that is, I'm not going to say Python specific, but it's something that's a little bit different based on the programming language sometimes. So in C++, it's going to give you a different answer, which is just something to be careful of in 202. But for right now, this one always assumes that, so there's really two possible, well actually there's infinitely many possible answers, but there's two possible answers that are kind of reasonable. The first answer is that the remainder 3 is equal to 0 times 3 minus 2. So that's a reasonable statement. And here's the other reasonable statement. The other reasonable statement is 3 is equal to 1 times 3 minus, or I'm sorry, negative 1 times 3 plus 1. where the remainder is 1. So either the remainder is -2 or the remainder is 1. And so the thing is that it's really a question, in a sense, it's actually a question of preference, but it's also a question of, like, if you remember back to, basic elementary school division, your teacher should have said, remainder is bigger than 0 at some point. So your remainders are always positive. Or, I guess, bigger than or equal to 0, technically. You could have a remainder 0. So this is what Python gives you. Now,
damn math, you scary.
On the other hand, and this is why I don't think it's good to overlearn this fact, C++ gives you -2 when you do the mod. So it's important to remember that they are not. This is something it's true in mathematics. It's true in Python. But when you get to other programming languages, you have to remember that if you ever have a negative modulus, you might have to check for that and add the divisor onto it again. Okay, so let's go back and let's ask the question that Ben asked. How do we write an if statement that checks if an integer is even or odd, really? And so the answer is, when something is even, then we know that. Well, that's a good question. When something is even, right? So 4, for instance, and we mod it by 2, we get 0. Say 18 mod 2 is 0. 22,000 for 46 mod 2 is 0. But if you do anything odd, say 3 mod 2, that's 1. If you do 7 mod 2, that's 1. If you do 19,899 mod 2, that'll be 1. And so the question is, why is this the case? Why? So, well, I guess it's really kind of, the right answer is that it's the definition of even odd. So the definition of even versus odd is even can be written as n is equal to 2k for some integer k, which means it's mod 2 is equal to 0, which means, I guess, mod 2 is equal to 0. I can even just say n. And then odd is something that can be written as 2k plus 1 for some integer k, meaning that n mod 2 is 1. So there we go. So how do we write an if statement that tests if something is even? What we can do is we can say if, well, I guess we'll input the integer. N is equal to input tell me an integer. And what error am I going to cause if I do this? I keep doing that. There we go. You might use mod in homework too. Yep. So,
debugging problem? Are we debugging this?
Well, not you.
But I'm worried about my grade in this class.
Don't worry. I was asking the students to debug, not you.
Oh, okay.
Yeah. Ah. Yeah. Yeah. Because if I don't do that, right? Let's say I don't do that. Quit, I guess. And then now tell me an integer, right? So now we're down to here. So tell me an integer. The integer is going to be 17. And then it's going to say, type error, right? Not all arguments converted during blah, 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 right? So the point of this is that you have to look back in your code and you have to figure out probably like if you get a type error or a value error, the most likely thing that's happening is you forgot to do a cast, right? That's the most likely thing. So actually, let me actually just tab the rest of this in so that it doesn't run. Okay, so tell me another integer. Let's try 16. Oh, that's even. Right? Tell me another integer. 19. Yeah, so if you cast so let's cast int on input. Oh, let's just do it on this, and it'll just, I think it will just break. So if you do 3.2 like this, what we'll do is this. So it doesn't know that you're about to use the integer in a. It doesn't know that you're converting, that you want to convert this float to an int. The first thing it tries to do is it tries to take your string and understand it as an integer. But it sees the decimal point. And now if you type in a decimal point, I think this, oh no, even that breaks. So the point is that you can't even type in it doesn't even like it if you type in the decimal point, right? So even 3.0 won't cast to an integer, right? So that's the one thing that you have to remember, is that int will only cast things that are integers. It will not cast anything that even has the form of a floating point number, meaning that it has a .0 on it, right? And you're like, well, but this isn't, 3 is an integer. I don't care that it has this decimal 0. Well, Python certainly does. How do you make it do both at the same time? Well, okay, so if you really wanted to do something like that, what you would do is you would cast it to a float first, and then you would say something like this. Because at this point, what this is doing is it's converting from a float type, which has decimals, to an int type without decimals. And this will probably work. So if we enter 3.2, okay, it doesn't print anything because we don't. So let's enter 4.2. So it tells me that's even. The reason why it tells me that's even, let's print out F and N. So, thank you, Ben. I mean, I don't even have time to say these things.
I'm sometimes, instead of being a distraction, I help out, but
yeah, unfortunately, it's just too fast, right? So I can't even keep up. What happens if you modulo a float decimal?
Fire, burning. Yeah, it's just your computer's going to erupt into a.
Unfortunately, I think in Python it actually.
Inferno.
I think it works. Yeah. The remainder, you see, is this, right? So this is something that doesn't work in other languages. This is some kind of this is Python special.
It's Python magic.
Yeah, I mean, and you see here an example of something called round-off error or whatever, where you see that we entered 4.2 exactly, and 4.2 minus 3 is 1.2. So it should not be 1.2000002. It should not be this. This is not correct. But it's very close to correct. So the question is, what happened there? And the answer is that computers can't store floats exactly sometimes, most of the time. Basically, the time when they can is when your float is something like, so if your float is something like 1/2 or 1/4 or 3, well, no, it can't store 3, the numerator 3 can't store that. It can store things like this, exactly, like fractions with denominators that are powers of 2. But otherwise it has trouble.
Christina has an excellent question. Why wouldn't we just use float for everything, unless we only specifically want an int? Why is int our default? That's a great question.
All right, Ben. All right. I might have to dump you. So.
Wait, did you just explain it? And
No. I'm just. The problem is that I'm saying words pretty constantly. There's a limit Remember that the human speech patterns have limits as to the amount of words said per second. So let's see. So the question is a good one. So we can't use float for int. No. What she asked is we just use float for all int unless we only want an int. Basically, you could do that. But this is the one example where you might not want to. The reason why is that floats are kind of a little bit iffy in terms of like equality, because sometimes in this case here you see that 4.2 minus 3 was not exactly 1.2, whereas with integers it will always work out exactly. So if you need your result to come out exactly and you don't want to even chance it to round off error, then yeah, you want to use ints when you deal with. So basically integers can be stored exactly. Floats are always stored as kind of an approximation. I think that's the best way to say it. So it's safer to use integers when you want an int. It also forces the user to enter something that's not kind of like random. So for instance, like if you say enter 1 to go into this menu option, enter 2 to go into this menu option, and you say, and the user gets to enter 1.5, and then somehow your code converts that down to 1, I think that it's better if your code shows an error.
Right.
Because it shouldn't let you do that.
Ints are smaller, right? So the babies. Well, yeah, that's a whole other can of worms. Yeah.
I mean, a float is 4 bytes, and int is 4 bytes. A double and a long, they're the same as well. I don't want to have that discussion. So
sure. Yeah. No, we're way off our conditions world.
Right. Okay. So now let's talk about some other things about conditions. So, for instance, let's say you want to do the other case. So here, this is printing out something if the thing is even. But what if we want to also print out something if it's odd? So there's a keyword for that called else. And basically what this is going to do is it's going to evaluate this if statement, and if the if statement is true, it'll do only this thing, right? Only this when true. And if it's false, it will jump to here and execute this code, not the if code. So it evaluates this if statement. If the if statement is true, it'll print out it's even. If it's not true, it'll print out it's odd. And the good news is that we don't have, in this case, this works as code, but it's also correct as logic, right? Because a number is either even or odd. The trick question I always ask is 0 even or odd? And yes, let's see. So tell me an integer. Let's say the integer is 3. So it's odd. And so you see here that what happened is it didn't execute the it's even statement. It executed the it's odd statement. Let's do another one. Not 7, 8. So you see here it executes the it's even statement, and it doesn't execute the it's odd statement. So it only does one, and that's the nice thing about if else, right? So now you don't need an else for every if statement, right? So you saw if statements don't require else, but if you want a catch-all, right, at the end, this is how to do it. This ensures that if all of your conditions, and we're going to get to else if in just a second, if all of your conditions are false, then it will still at least execute the else. Yes, so 0 is even. And the reason why is 0 is equal to 2 times 0 plus 0. Or alternatively, you can just write it as 0 is equal to 2 times. And that is the definition of an even number, right? It's like the most even number. The reason why this is a trick question is because everyone thinks I'm asking, is 0 even or not even or odd, positive or negative, right? And 0 is neither positive or negative, but it is even. Okay, cool. All right, so what else do we want to teach? Okay, so let's do some elif business. So let's make an basically sure. Let's say int input enter a day of the month. Now this was a homework problem, but I'm just going to convert it into an example. So this is an interesting example where let's look at this month. So September starts on a Tuesday. So September starts on a Tuesday. And so what I'm going to do here is I'm going to show you an example where we can use modulus and elif statements to basically print out the day of the week. So for instance, at least of September. So I should say this September. So basically what's going to happen is we're going to enter an int, which is the day of the month, and then we're going to have if n modulo 7, and now why am I modding by 7? If it's equal to 1, I'm going to print Tuesday. And now there's a bunch of other cases. It could be Wednesday. So what if I want to do another statement? Well, I can't just do else print, right, Wednesday, because that's not going to work. Yeah, I'm modding by 7 because there are 7 days of the week, as far as I know. So I want to check if, but you see that the second of the month is a Wednesday. So if n mod 7 is equal to 2, I want to print Wednesday. And if n mod 7 is equal to 3, I want to print out Thursday. There we go. And if n mod 7 is equal to 4, I want to print out Friday. And if it's equal to 5, I want to print out Saturday. And if it's equal to 6, I want to print out Sunday. Else print, well. So there's a few things that we can do to fix this code. So the point is that we want to make sure. Now, this is well, there is no Monday. That's a good question. So so there's a few problems with this code, but we're going to fix them, right? So yeah, the September starts on a Tuesday, so September 1st is a Tuesday, and so that's why n mod 7 is equal to 1, print Tuesday. Okay, so we print Tuesday. Now we want to make sure that only one of these statements is ever executed. Now here's the problem with using if statements like this. It's theoretically possible that if, now you wouldn't do this in this example, but if you ever reset n, if you said, okay, so now n is equal to 5 here, this is what would happen. So let me do this. There we go. So let's enter September 3rd, and it's going to print out Thursday, Saturday, what? Right? So the problem is that it's reassigned n in here, and so you see that this if statement executed, and it was false, so it didn't print. This if statement executed, and it was false, so it didn't print. This one was true because I entered 3, so it printed. This one, and now it changes the value of n. So what if we want to prevent this from ever happening, right? We don't want this to be able to happen. And so maybe another coder comes in and they do something like this, right? And you want to prevent this from happening. So what you can do is you change these to elifs. So elif, in other languages, they're usually called elsif. So normally they're called elsif, but in Python they're called elif for elif. You can't actually lock the value. That's the problem. I can reset n is equal to 5 here, but it'll actually be okay now. And let me show you why. So I'm going to redo this now, and I'm going to print out, I'm going to put in 4, which is going to execute this print statement of Friday, and it's going to do n is equal to 5. But you see here that it didn't actually evaluate this elif statement, right? Now, why didn't it do that? And the answer is because once Python sees if, and then it starts to see all these elifs, what it does is it goes until it finds one if statement or elif statement that's true. Now, there's only allowed to be one if statement here, but you can have as many elifs as you want, right? So the elif number is essentially unlimited. You know, you can have 100 of them, you can have 1,000 of them, and if you have 1,000 of them, we will take off points. So don't do that. You will never, if you ever have 1,000 elif statements, I promise you, you're doing it wrong. Okay? Generally, the limit should be like, is 20 or approximately like that. Even 20 is ridiculous, but it's not. I'm saying 20 is not impossible. It's not ridiculous, but just don't do 1,000,000 of them. But there's technically no limit as to the number of elif statements. But the good news about elif is that it only allows one to be executed. So it prevented that little hacker bug that I inserted, right? So, okay. Now I've also done another bad thing here. And that bad thing is I've forgotten about Monday. And, well, I didn't so much forget about Monday. But I remembered that when we gave this as a homework problem, everybody forgot about, well, not everybody, about a third of the people forgot. That's the correct percentage. A third of the people forgot what happens when you get to the 7th of the month, right? What happens when you get to 7, right? 7 mod 7 is what? Right? So they wouldn't write this extra statement here. What they just did was they're like, oh, I'm just done. Yeah, so 7 mod 7 is 0. So here we've checked if n mod 7 is 1, 2, 3, 4, 5, 6, but there's still another possibility, right? And that was Monday, right? Monday. So that is the idea here. So if we enter, for instance, the 7th of the month, it'll come out as Monday. If we enter the 14th of the month, it'll come out as Monday. If we enter the 21st of the month, it'll come out as Monday. And if we enter the, 70th of the month, it'll come out as Monday. Now, of course, you're like, wait, there's no 70th of the month. Is there a way to fix that? Is there a way to prevent us from doing this, right? And the answer is yes. So so let me just say one thing about all the code that's in here. You notice, right, so that's a good question. What if the input satisfies more than one elif statement? So, put another elif for 0. You could also, this is equivalent to saying elif n mod 7 is equal to 0, right? This is equivalent in this very specific case. But generally, yes, that's correct. It will stop at the first one that's evaluated. And so, for instance, let's do an example of that. So let's say that let's say x is equal to int input enter num, right? Let's say if x is bigger than 0, we print x is positive, and then elif x is bigger than 1, we'll print x is bigger than 1. Now you might say, so it depends on what you're thinking here, but you might say something like, oh, well clearly, let's just enter the 14th of September to get Monday again. Now we have to enter a number. Could we just do 7 mod 7? I suppose you could. I mean, this is not the only piece of code, right? You could start it with if n mod 7 is equal to 0. I was just doing this to show you what happens and using else, right? But what happens here, right? If x is positive And then here it says x is bigger than 1. So actually this is weird code, because if I enter 5, it's just going to print out x is positive. It's not going to print out x is bigger than 1. And so your question is like, why did it only print out? Yeah, elif makes sure that it only executes one block of code. And that usually would you use this kind of structure when you're afraid that one block of code might be executed and then the next block of code might be executed. Now, let's say that you wanted, right? Let's say that you want both blocks to be executed. Then this is what you have. And so let me just say that on a lot of tests and quizzes, we will write stuff like, if x is bigger than 0 and if x is bigger than 1. And so we try to trick you into saying that, oh, like it's going to print x is positive and it's not going to print x is bigger than 1. And the reason why you might think that is because you're thinking elif, right? But you have to realize that these are two, right? Technically, it's okay if you put as many lines as you want in between them. These are two separate if statements, right? This if statement evaluates, and then it's done. There's no elifs, right? No elifs, no else. So then this, then this one evaluates. Okay. What about putting another elif for 0 and use for error if input is bigger than 30? Yes. To Ayush, yes, you can do that. So Monday again, I don't know why I always pick 7, because 7 is divisible. But here, if we want to enter a number, then I just hit 5, enter, and now it prints both, right? So now what it's doing is it evaluates this if statement, and then it evaluates this if statement, and they don't talk to each other, right? They're separate if statements. So, all right. So, I think at this point, maybe we'll talk a little bit about logical operators. And what I mean by that is and, or, not. Okay? And then we'll talk a little bit about nesting, and then that'll be it for if statements. So, let's talk about and, or, and not. So what if we want two conditions to be true? So let's tab in all of this code so we don't have to worry about any of it. I'll untab it for the GitHub, but I'm just leaving this tabbed in so that we can just have one thing happen at a time. So let's say that we make a variable called s, and we're going to make it hello, and we're going to make a variable x, and we're going to make it 2. That's a good question. What does tabbing do to your code? Well, it would break it, except that I have this little function up here. We haven't taught functions yet. Basically pretend that I'm just commenting all this out, or deleting it for now. But what it's actually doing, what tab actually does in Python, is that it moves you into a block of subcode. So for instance, if you have an if statement, and we'll talk about it when we do this if statement, we'll say if s is equal to, say, hello, and x is equal to 2, whoops, then we can print, yep, we're good. Else, print, no good. So what this is going to do here is it's going to test if s is equal to the string hello, and it's going to test if x is equal to the integer 2, and if they both are true, right? So and, basically the truth table for and, well, actually, maybe I'll just draw it. That's a good thing. It's the fastest way to do this. So if we have A and B, then we'll make this A and we'll make this B, and A can be true or false. B can be true or false. And so it's like multiplication. Yeah. If you consider true to be 1 and false to be 0, and is like multiply. Because in this case, what you're going to end up with is 1 times 1, or true times true, is true, or 1. True times false is 1 times 0, so that is false. True times false is false. And false times false is false. Right? So that is true, Sammy, but there's also the keyword not. So we'll talk about both things, right? So there's not equals, which is done by the exclamation point equals, but there's also the logical not. So if you have A, which is true and false, then not A, and it's literally the keyword not. Not A is false and true. I guess not is actually like 1 minus A, right? Because if this is 1 and this is 0, then this is 0 and this is 1. But you don't have to think about it like that. Okay, so let's talk about and a little bit more. So here, okay, let's just run this, see what happens. And it says, yep, we're good. So we know that these are both true. So what if I change one of these things, x is equal to 17 and s is equal to hello? Then it's probably going to print no good, right? Because not both of these are true. No good. And so what if I change this to Obi-Wan? And I change this to 2. No good. So the only way you can get through this if statement, right, with the and, I'll talk about or in just a second, but the only way you can get through an and if statement is if both of these things are true. And so there's actually, you can do it multiple times. So for instance, you can even have three and statements like this. The way it evaluates, I think, is probably left to right, so I think it evaluates algebraically. Something like this. So it'll evaluate this and statement. And if this and statement comes out as true, you cannot use, so I know you C++ and Java people are like, no, it's and or, right? That's and or. And I say, no, not in Python. Sorry. Yeah. See, PyCharm is saying, what you doing? What you doing, man? Don't do that. That hurts. It's not an operator. I don't understand. So yeah, you have to be careful. All right, but let's say that you want, and let me get rid of this and equals 5 business for now. Let's say, well, okay, I'll leave it. Who cares? So now let's say that you want to write an if statement that executes if s is equal to hello or x is equal to 2. Well, I'm going to copy paste this statement. It's more simpler to put and versus or versus Java. I don't know if it's simpler or not. I mean, if you get used to the double and the double or in C++, eventually it seems really natural to you, and any language that doesn't have it, you think, oh, why doesn't it have that? And then when you get used to the Python, you say, well, obviously you should do English instead of the symbols. Yes. So, yes. Thank you, Sammy. Yes, that is correct. So double equals tests for equality. I was going to say equivalence. I guess equality and equivalence are the same thing. Single equals assigns the left-hand side to be the right-hand side. How would you run a specific block of code? I don't know 100% what you mean by that. So I'm going to just evaluate. So if s is equal to hello and x is equal to 2, then I think that we'll change this to an or. So what happens if we change this to or? And remember that x is equal to 2 and s is equal to hello, so this is right. So what if I change s is equal to blah? So the good news in Python, I don't know if he's talking about break. I think he's talking maybe about, like, I think he's really talking about if statements, really. That'll run a specific block of code. So this will execute because x is still equal to 2, right? Oh, I don't want to talk about Jupyter. So you see here, this says, yep, we're good because both are true, or all three are true. And here it says we're good, even though this one is false now, right? So keep in mind that you can actually print out the result of equivalence statements. So I'll just do that, and we'll see what happens here. So you see what happened here, right? S is equal to hello, that is false. X is equal to 2, that is true. And S is equal to hello or X is equal to 2, that is true, right? And so let's just look at the truth table for an or statement, and then we will know the truth table for an or statement. So let's do it the same way we did before. I'll do A or B here. And so then here we'll do A, B. So A goes this way, B goes down. I guess this is true, and then this is false. This is true, and this is false. So or just means that one of them has to be true, not both. So true and true is true. True or false is true. True or false or true is true. So remember that this is the reason why we have two cases like this is because this is false or true versus true or false. In 203, when you learn about equivalence relations, you'll learn about symmetry. And so or is not an equivalence relation, but it is symmetric at least. So this is true, and this is false. Yeah, it's kind of like an A plus B. Yeah, or is like A plus B in a sense. As long as you agree that 1 plus 1 is equal to 1 or something like that. Okay. So basically the only way to make this not execute is if you set, whoops, that's actually a capital. Oh, it must be caps lock. Yep. So, yeah, that'll also work where you have bigger than or equal to 1 versus equals 1. So you see here that if we set x equal to 17 and s is equal to blah, then the s prints out false, the x equals 2 prints out false, and this or statement prints out false. So then the if statement evaluates as false, so then it goes to the else, which prints out no good. I know I've kind of said a number of times. So for instance here, okay, I think that's it for logical operators. The only thing I want to say about logical operators is, the last thing to say is that they have, our logical operators have low precedence. And so the question you should ask is, what the heck does that mean? And so the answer is, remember that you have basically an order of operations, right? If we go from high to low, we have to evaluate the things that evaluate first. So parentheses always evaluate first. And so whatever's in the parentheses gets evaluated, and that gets evaluated based on its order of operations. And then we have exponents. And then we have plus, minus, and, oh no, I'm sorry, wrong. Times, divide, and something I haven't talked about yet, integer divide. Let's see here. Looks like you are going to be removed. Okay. Okay. And then there's mod. Okay, very good. Cool. All right, and then so pow is in the pow is a function in the math import module, I guess you'd call it. So we use the star for right now. Yeah, I banned him. I banned him. Oh, I guess Ben banned him before I got to, but we all banned him. Everyone banned him.
Everyone.
Yeah.
Man.
Thanks, Ben.
Yep.
Yeah, gotta moderate that nonsense. So, okay. Well, these are the arithmetic operators. But then there are the equivalence operators. Or really, you might call them comparisons. So, for instance, you'll have like less than, greater than or equal to, less than, or I guess this is less than or equal to, greater than or equal to, not equal to, and equal to. And these are all of the same level of precedence. But the point is that now we have the logical operators. And logical operators are at the lower end of precedence. So the highest thing is not. So not gets evaluated first, and then and or get evaluated second. And so remember, then the last rule of order of operations is generally order of operations goes from left to right. The only exception to that, which I'm definitely not testing, is that star apparently goes from right to left, which is horrible, but and they should have standardized that, but they didn't, so it's the weird one. So anyway, so the point that I'm making here about precedence is that the point is that if you have a bunch of stuff, like if x is equal to 3 and let's say x plus y is less than 18, print high, then the question is what things are going to happen first. And the answer is generally when you're doing all this, and this is exactly what you want to have happen, you have the arithmetic happen first, right? Arithmetic generally happens first. And then the comparisons will happen. So x is equal to 3, and this comparison will happen. And then finally, at the very end, the and will execute. And the reason why you want this to be true is because you don't want you definitely don't want something like this, right? This would do things that you really don't understand, right? If you use POW on homework, you will lose almost all points for that problem, yes. So, basically, there's secret parentheses here. The secret parentheses are these. Okay. So, all right. So this is actually how the thing is secretly parenthesized. And this is the way that you want it to work, because you want it to check if x is equal to 3 and if x plus y first, and then that sum is less than 18. So let's actually see what happens here. Okay, so I guess x is not 3. Is x 2? Yeah, x is equal to 2. Let's make it true. And y was set to be 17, so maybe it will change this to bigger than. Cool. Is it equal to... Who knows? Okay. Well, I mean, it's not even an operator, right? It's a function. So, okay. Cool. So I think maybe we'll end the lecture here because I'm 2 minutes over. Again, math.pow is a function in a library. I don't know what functions are yet, and I don't know what libraries are yet, so we cannot use anything that's a function or a library yet. Yeah, of course, we're doing functions in like 2 weeks. So, I mean, but I'm just saying, for homework 2, just if statements, just, we are limiting you to only the things that we've currently taught so far. Yeah, that's the exact point. So all of this stuff, right, it comes eventually, right? But we've just talked about if statements today. I didn't have time to cover functions. I didn't have time to cover recursion. I could have. So no downloading lib. Don't download any modules. You don't need to download any extra modules or import anything. At least for the first few. When does homework 1 due? Check the homework 1 assignment at the top. It always lists the due date. Oh, well, okay, you can tell him.
Is this when I can turn the distraction knob up to 1.0?
You can distract now.
So these functions, you said this function word. Does this have anything to do with conjunction junction?
Certainly not. I have no idea what that is, and I don't know what functions are. I really don't know anything about what you're saying. I am very confused. And the sad fact is,
you seem a little disturbed by it too.
No,
You're like, I don't know what it is.
No, the funny thing is that
scary.
actually some people believe me when I say that, and I'm like, I don't know what functions are, and people are like, really? A function is like a little subroutine that your program can call. I'm like, yes, it's on the syllabus. I'll teach it in 2 weeks. But
we should get the that's the joke.jpg.
I know, right? I definitely need that because sometimes. Well, yeah. So I say things and people are like, "Wait, really?" I'm like, "No." So, you know how things are.
Mm-hmm.
Incidentally, class is now adjourned. I'm just going to chat with Ben until we get sick of it, and then that'll be the end of the lecture.
Yeah. So. Right, this is going to be your 4-hour lecture as we talk about birds and stuff.
Oh, thank God, no birds. Birds are your thing.
Yeah, birds are my thing. Yeah.
It's also one of the words that you just say when you're like, I need a word, and Ben's word dictionary just comes out with bird.
Bird. Yeah, 100%. 12 is the number I come up with. Bird is the word.
Bird is the word. Yeah, you meant to do that, right?
The name is Jeff. If I need a name, Jeff pops into my head. Don't know why, but it's Jeff. We have a TA Jeff now, right?
Oh, you want the outro? Here it goes. Is it going to be on GitHub? Yes. Yeah. Oh wait, can you still hear Ben? I think they might not be able to hear you in the outro. Yeah, because I've actually now I'm really confused as to what happened. Maybe I'll scene it and then I will turn these things off and then we'll be in the darkness. I'll put up an image. What image should we put up? There. Oh, nope, that's not right. Not really. Yeah, yeah. Good. I don't think they can hear you right now. I'm very sad about that. Let's see. Desktop audio. Desktop audio. Audio. Let's see. Can you talk now and see what happens? No, negative. That ain't working. What have I done? How about this? How about this? Oh, it captures stereo.
Ooh.
And that's where you are. You're an audio output capture 2. I need to rename that as like desktop.
As the Ben conduit.
Yeah. Well, unfortunately, there's the desktop audio, which is no longer desktop audio for whatever reason. And yeah, it's just absolute chaos, man. There's nothing but chaos in the universe.
Is it because you were DJing and you got all of your audio devices messed up?
You know, if I were a better DJ, then I think, yeah, maybe.
Yeah. Oh, that's right. This is a fresh lot of students that don't know about your whole DJ Eric thing.
Yeah, EJ the DJ.
Mm-hmm.
There we go.
Wait, so am I audible now?
Yeah, you should be audible.
Oh, okay. So people, okay. So they all know about your DJ Eric times.
That's right.
What's Mob What? What's the music box up about?
Music box?
Drop some beats. Well, I hope that's not a spelling error because you don't want to drop any fresh produce.
Well, the only thing that I don't do is I don't play any music on these channels because YouTube's auto copyright system is mega, like, aggressive.
Aggressive. I started using the free YouTube.
No, I use the free YouTube music, but I don't use like anything that is even potentially, because like otherwise I would have to make sure I've downloaded all my lectures, and then I'd have to edit out the part with copyrighted music, and then I would have to re-upload the videos, and then everybody would be like, "Where'd the lecture go?" And I would say, "I don't know, man. What happened to it?" And then YouTube would be like, "I'm angry at you," and I get to avoid all of that. Yeah, so. Yeah. I wish we could play music. That'd be fun. I feel like maybe I could do it on Discord, like a Discord stream or something, or like maybe a Twitch stream. You could do it. I don't know what Twitch's policies are.
We just need to perform our own jams. We need to jam.
Yeah, I mean,
I've got a really good. Like, my kazoo embouchure, unrivaled.
Oh my. Yeah, I guess. Yeah. So one of our favorite people says that Twitch is lax about it. So maybe we should just go over to Twitch and whatever, play all kinds of crazy music, really do it up right.
Excellent. Well, we got I won't say this here because I don't want to get you committed to anything.
Oh God.
But
yeah, you were about to you were about to do something.
I was, but I stopped myself. Which is good. Yeah. That was really useful. So how you're basically almost done teaching 201 for the semester, right? You got conditionals. That's pretty much it. Just have loops and then it's most of it, right?
Yeah, so we just have to teach loops, functions, and basically the rest of the course. So it's not much.
Yeah, Nick has not been smote yet. You know what I keep realizing is that people have the ability to like look up stuff all the time, and we miss out on all these discussions where we think about like what might be true about the world, like how far a grasshopper can jump. Like, yeah, we could just look that up, but what do you think it is?
What?
Never mind. Never mind.
Are you just amazed that the internet exists? Is that what you're saying?
I just love the internet. I love technology. Hey. Yeah, I've just been like writing assignments out, and my brain is like in a strange place. So I don't know. I don't have anything of value to say, which isn't a big deal because I almost never do have anything of value to say.
Oh, you see, I was cleaning up my desk and I was doing stuff. I made a decision. I'm gonna have to get I don't know. I think I'm gonna actually have to just run a file server or something. Also, I managed to introduce a bug into the authentication system for 2 students on my Discord bot.
Has the Discord bot gone on a murderous rampage yet?
No, actually, I'm gonna say that it's worked nearly. It's been like a 99% functional thing.
I see. Does that mean it's biding its time for the murderous rampage?
If it is, if it is, then it's my fault because I've written a huge amount of the stupid code now, and so it's like some merger of our 2 pieces of code are gonna kill us all. And
I'm worried if it starts annexing parts of other
Sudetenland
courses. Yeah, we don't want to begin.
No, I mean we're neither. Well, I don't know.
Good thing we use MongoDB and not MongoDB. Then it would have some good strategies to draw upon.
Genghis Khan would be happy.
I'm pretty convinced they must have had dinosaurs or something.
What,
to conquer as much of the world that they did at the time that they did it. The fact that people even moved that far. What year was it?
It was around the 1300s.
Yeah.
Well, you also have to remember
how did they get so far?
Right around that time, I think it was right before and after the Black Death. So Europe had just got plastered.
That's true.
And they had also, I mean, I'm not gonna meme it, but maybe I'll meme it. Horse archers are apparently the best ancient / medieval weapon in all of history, because I mean, if you remember back to I think it's what is it? The Battle of Carrhae, where
Sure. Yeah, I definitely.
Where the Romans were defeated, right? And they poured molten gold down the throat of what's that guy's name? Crassus.
Jeff?
No, Crassus, dude, Crassus. And yeah. So Mount and Blade. You'll learn about horse archers in Mount and Blade. I had a friend who always talked to me about Mount and Blade, and he always called it Mountain Blade, and it confused the literal garbage out of me because I could never find it. I was like, I'll buy the game. And then I looked up Mountain Blade, and I was like, does not exist. DNE. So that's what I wrote on my homework.
But I still think, I mean, horse archers overpowered, right? OP horse archers.
Apparently no one modified the INI file in actual history, so they just stayed OP.
Oh, so history didn't get a balance patch.
Yeah. That's what I'm saying, is basically every faction in history that learned horse archer tech basically had a period of absolute dominance and then collapsed for other reasons. The Mongolians basically had their ancient tribal system, which they were unable to overcome. When Genghis Khan died, they all had to go back to Mongolia to have I know in Arab culture it's called a jorga, and that's what it's called in Afghanistan, but it is something similar to that, like a family council to decide who takes over.
Basically, they had a big meeting with
human
resources.
But the problem was that they all had to go all the way back to Mongolia to have this meeting. Because they couldn't be let's just have it.
That's what sucks when you have to talk to HR, but they're let's go talk at an Applebee's that's 15 minutes away, and you don't even want to have this conversation. So you have to drive all the way across Eurasia to get home to be look, guys, we squandered all of our conquests. You just don't want that.
No.
At least with Applebee's, I guess you could can you get the bloomin' onion at Applebee's? Is that an Applebee thing, or is that just like a Outback or something?
Um, you can get a similar type of thing at other places. I don't think you can get them. I don't know. Can you get them at Applebee's? I haven't been to an Applebee's in a long time. I love the bloomin' onion at Outback. Um, though Outback's quality has declined over the past 10 years, which makes me
Right.
sad because their cheesy fries used to be basically the best thing in the universe, and now they usually overdo them. They're usually like too burnt and just kind of they're good, but they're edible and fine, but not something that you're like
So yeah, just to tie it
longing.
all back together,
Yeah.
how much of the world would you conquer to get back the good Outback cheesy fries?
Uh maybe 20%.
20%. Okay. And is this in like a temperate zone or
Well, I mean, if we have to take some of like the Russian tundra, then like 30%. Because I
well,
mean, there ain't nothing out there, right?
you could get
Or there's
more,
not a
but
whole
it's
lot.
gonna yeah, though, you might lose some
Yeah, sorry, Siberians. I don't mean to
stuff
offend you.
to
You
them.
definitely exist out there. You're very good people, but
Yeah,
there just numerically are not many of you. Um,
the people wonderful, the land value not so great.
it's getting better. They've had some time in the Russian steppe, or not the steppe, the tundra, that's reached like 90 degrees recently. So it's about to be a tropical paradise on the Baltic and
That's true.
on the Arctic Sea.
Oh,
So
we
yeah,
should buy low.
buy
Yeah, go
low.
up there, buy some Siberia for nothing, for like a few turnips
And
or whatever.
don't just buy the oceanfront land, because that will get, climate change will take care of that. You buy
Exactly.
a few miles back, and that's where the real money is, right? Won't get flooded, but it'll also be beachfront property in 50 years. So excellent. I guess your
Yeah, this
grandkids
sounds good.
can make billions on that kind of real estate deal.
Well, we have a retirement plan now, you and I. We're gonna do this computer science
Yeah,
teaching
except we just
hustle.
told 42 people.
Hey, look, there
We
there's enough
probably-
Siberia for everyone
Yeah.
in this stream right now.
I guess that is the good news, is that there's plenty of like, if you ever ask, man, there's just not enough Siberia, I'll tell you, you're wrong. There's plenty. So
So so it sounds like the plan is we're gonna buy all that up, and then you'll get your cheesy fries, I guess. Because there's definitely potatoes.
oh no,
We
I
could
thought
probably get
you
some
meant that I had to
cows
conquer them using an army.
Well, I guess it's modern day conquering.
Oh,
So-
well, that's like then you're just saying like buy.
Yeah, that's true. That's true.
There is a sort of shame that we live in the modern world. Because, if we were born in the 1300s, it is theoretically possible that we could have.
I'd be so dead. I'd be 8 different kinds of dead. Are you kidding me? Oh, it'd be bad. I would. Ugh, a world without air conditioning? Come on, forget about it. Ugh.
Yeah, well, that's Italy.
That's true. When I was in Italy, there was not much air conditioning.
And I was staying at a house, and they hadn't invented screen technology for the windows. And so, like, you had to close the shutters at night to prevent mosquitoes from coming in. And I was like, I actually re-screened the windows on my own house. And you know how I did that? I bought some screen, and I did it. And it was actually like a 2-hour job. So, like, it was harder to get the screens off than it was to re-screen them in the end. So I was just thinking,
I gotta tell your students this. I joke about you being DJ Eric, even though it's totally true. It's an underground nightclub. You guys wouldn't know about it. But
Yeah.
You're definitely very handy. You and Professor Dixon might be the handiest professors in the department.
well, you know why? I was the only person in the math department who could basically change a tire.
Oh, I see. You
So-
were nominated as handyman. For
So
the math department.
so when all of my like grad student friends, would have flats, they'd be like, "Oh crap, what do I do?" And I'd be like, "Fine, I'm coming out." and I'd be grumpy too. I mean, I don't like doing it. It's not my thing, but I have had to do it.
Keep doing it. Didn't you change brake pads recently and
Uh,
stuff?
no, that ended up not happening because they ended up selling that car, so I never had to do it. But I bought the brake pad. I was about to do the fix, but the fix became nullified in the end. It did not have to be done. So
It blows my mind thinking about brakes. I promise I have a follow-up for this, but like the fact that it's just like a hydraulic tube with brake fluid in it, and you push on it and it squeezes the tires. You're just pushing on a tube filled with fluid, and that's what makes your giant car stop. Like that is hard to like. It feels, it's like planes. Whenever I look at planes and I see them, like big planes flying over, there's the lizard brain in me just cannot accept that big heavy metal tube is suspended by those little wings flying over. Just like when I press on the brake pedal, it's like there's some freaking high C, some like Hawaiian punch in a tube that's making the whole car stop. It's crazy. Is this still a lecture? This is not a lecture. This is just us pontificating. The lecture's been over since class has been over. We're just here to
So I think
give you guys some social interaction and ourselves, really.
Yeah, I mean, I do agree that there is an asymmetry in starting versus stopping of a car. Like, you have this gigantic engine, right? And it has an oil pan, and it has like a giant, air intake, and all these parts of the engine, right? And the thing, it has all these cams and shafts and all kinds of stuff, right? But look at the brakes. The brakes have
a tube. It's a tube with a squeeze.
Very small tubes relatively, and
yeah,
and they just feed, and they're just basically what? They're like hydraulic based. It's like a hydraulic system since it's a liquid, and there's just brake fluid that pushes on two pads and creates some friction, and that's it. So there is definitely an asymmetry between the two types of systems. One thing that will make, I don't know if this will make you happy or not.
Are not powered by explosions like the engine.
Well, that's also true. Well, the one thing to keep in mind is that for rocketry, like spaceflight, that is something which is symmetric.
Right, it's the opposite. Well, that's true.
If you have to use the same engine to accelerate and decelerate, and you have to use the same amount of fuel to basically get the same, delta V, I guess, as you might want to call it.
Correct. Yeah. Well, but then you also have the
someone tried to check into a lab.
The entry. Someone tried to what?
Check into a lab, and we got this giganto error. Oh, nice. It explodified. It did not like their check-in attempt.
Isn't it fun having software in production?
It is when you can watch the exceptions roll in. Because, you're like, this code is perfect. And then you click go, and then you're like, this code is not perfect.
Mm-hmm.
Or even worse, this code is essentially non-functional. But this code, the code that we have currently is actually, I'm going to say working. Like, it's working.
Yeah.
Like, the check-in feature is not complete. So I don't know what happened there. I think they actually... Oh, so it tried to update them in the database, and it just didn't like that, because I don't think I have the database for the check-ins set up correctly yet. So,
I see. Yeah, well, we need to test. We need to practice what we preach. I mean, there's some tests in there, but we need more tests.
Yeah, I've been thinking about, a systematic way to build a testing suite so that testing will be easier to add to the process.
Have you seen the testing that's there now? It's pretty good. Works pretty well.
I have not, but I'll look at it.
It involved basically having a second bot that runs commands as if it were
right. So so what I'm going to need to do, I think, is when did the lecture end? Probably at about the 120 mark. If you're watching this, then you're too far.
Yeah, you've gone too far. Well, this is off the end of the Earth.
Yeah. I might even break it down into like 2 separate videos, or maybe just delete this part. I don't know. This might be a live stream only type of thing.
No, no, I think it should be a separate bonus hour. You could have a playlist of bonus hour stuff in your YouTube channel, where all of the uh, super secret, very exciting discussions happen, like about braking mechanisms in cars and
Well, cars
oh,
versus
I learned about
spaceships.
I found a beautiful way that Pythagorean triples are relevant to paper folding that I want to show you at some point. It's super neat. You'll probably be like, of course, math is wonderful, but
Yeah, I think the coolest thing about Pythagorean triples is that there's actually like a tree structure for them. Like you can start with, I think, 3 separate ones. I think it's like 3, 4, 5. What is it? Like 8, 11, 12, or something like that, and a bunch of other, and then maybe one more. And then there's 3 matrices that if you multiply those Pythagorean triples by those vectors or matrices, you'll get new Pythagorean triples, and it generates an entire tree structure, which is true for all Pythagorean triples. All Pythagorean triples are part of at least one path in this tree, I think.
sounds like a 341 project, my dude.
No! Maybe. It sounds like a 341 project 2. If we go back to 5 projects at some point.
Not a project 3?
I don't know. Maybe. The thing is that the mathematics is more interesting than the tree structure. It's a ternary tree, but it's a very boring ternary tree, if you know what I mean. I mean, maybe you could make a project out of it.
You're boring ternary tree. Gosh, look at you throwing shade at recursive structures.
Oh no, I'm saying that the tree itself is interesting. The structure of the tree is actually not interesting, which is why it's cool, because it's such a uniform structure. And that's like a beautiful
That's
thing
true.
about some things about mathematics that generate very uniform structures.
Yeah. So I'll just have to tell you about this Pythagorean. There's a stretch named after it in paper folding where if you try to scoot 2 bits of paper too close to each other, it causes problems. We'll say it causes problems, and you can rectify that problem by calculating some by basically using the Pythagorean theorem, and then if you use a Pythagorean triple, you get a very like clean, easy to fold crease pattern for the fold, which is pretty exciting. So I haven't had yet an opportunity to find a place to use a Pythagorean triple, but
That's sad.
it's good stuff. It's fun.
Yeah. It's difficult. I mean,
are you throwing homologies around now?
no, that's not homology. That's just Hom. Hom is the homomorphisms from a vector space to the real numbers, where
That's
v
good.
v is equal to the tangent space of a manifold evaluated at the fiber of the tangent bundle at some point p, I guess, is a way to say it.
I'm glad that you caught my trick question. Good.
Yeah, I mean, we can, there's some cool stuff you can do to generate a cochain complex with Hans, and then you can take the homology or cohomology of the cochain complex.
With Hans, who's Hans?
You see, Hans is he's a character from Die Hard. Hans Gruber.
I prefer to refer to him as Mr. Gruber.
That's Mr. Gruber to you.
I find it funny that like everyone always says Hans Gruber from the Die Hard movies instead of just Hans, right? Like Why does everyone use
is there
that
is there a
character's
second
last
Hans in
name?
existence? Yeah, is there a second Hans in existence? I don't know. I mean,
Oh, I'm sorry. I thought you meant the other Hans from Die Hard. All right, I think we should pack it in. We're already a half an hour overtime.
yeah,
There's
and
somehow
I
still
would like,
36 poor souls.
and the only this has nothing to do with our conversation, but I would like to keep the video under 2 hours, in general, because I've learned something. When I was uploading my stupid videos for 203 this summer, whatever, the YouTube takes longer to process videos that are over certain lengths. And any video that was close to 3 hours would take like 24 hours to process, whereas any video that was under like 2 hours would usually be almost up immediately. And also, when it did process those 3 hour videos, the first 2 hours of the video would process first, and then like the rest of it would just be gone for like a day.
Huh. Well,
Yeah.
noted.
So that's a hint. What I started to do was I would actually break my videos up into 2 halves so that wouldn't happen.
And then everybody can go to the bathroom and stuff. As a break.
Well, no,
Did you
I
make it in the-
I would give them a break time anyway, but I just wouldn't end the video. But then I just learned to end the video.
Yeah.
I was afraid that if I ended the video, that everyone would just be like, "Well, I'm gonna go to the bathroom, and then I'm gonna get lunch, and then I'm gonna talk to my family, and then I'm gonna go out, and then oh right, there was that second half of the lecture, and I didn't do anything but that. Probably unimportant."
Yeah.
I mean, isn't that what you would do? That's certainly what I would do. So.
Yeah,
I mean, you gotta see. That's the thing about honesty, right? When you're honest to yourself, and you're like, I would almost certainly do something like that.
I see. The thing is, I think honestly, I would stay and watch the whole thing. I want to say that I was like a cool kid with places to be, like, oh no, I'm gonna watch this. I'm gonna go, I don't know, chase butterflies or something. But I'd probably just sit around and be like, I hope Eric comes back. I want to learn about probability.
I am almost certain that is a minority opinion.
It might be. Yeah. All right.
I
gotta go. I require nourishment. I need sustenance.
Oh yeah, I made zucchini bread last night.
Oh, I'm jealous. I made a sort of beef bourguignon, so I'm gonna bourguignon the yon, whatever that means.
I think that means nothing, but very good.
Or it's some sort of crime somewhere. Anyway.
Yeah. Whoa.
Yeah. Ooh.
Yeah. Careful.
Yeah. I think that's when you like sneer at someone's goats, That can't be legal.
I couldn't say.
Yeah. Yeah. All right, I'm going away now. Bye.
Yes, go. Oh Lord. Okay, so that ends our live stream. That ends our discussion of goats and cats and Jeff. So, all right, I think I'm going to end the stream now. Go and have some lunch, everyone. Have a good day. Compute the, and remember, if you're ever in fear of anything, just compute the cohomology of a cochain complex and you'll be fine.